Alright, so in this video we're going to recap some things about inequalities and equations and how to graph them. But first, let's remind ourselves of what a variable is. And a variable is a letter or a symbol, we're going to use letters, that holds the place of a number we don't know. So it's just saying, hey, I don't know this yet, but we're going to find out. Okay? And then equations have an equal sign. An inequality, this in means not. And look, and then right here, it says equal. So that means not equal. Okay, so these are our inequality symbols. And remember that they open towards the bigger number. The alligator eats the bigger number. Okay, so this one is the less than symbol. This one that's less than but has a line under it is less than or equal to. It could be either of those. This one opening the other way is the greater than symbol. This is a greater than, both a line underneath it, so this is greater than or equal to. And then we're going to talk about how to graph them, okay? So if I want to graph the inequality, x is greater than or equal to -4. So saying some number, I want to know which ones are greater than or equal to -4. So to graph it, my circle is going to go on -4. And notice I didn't draw it super tiny, I didn't draw it super big, and I have not colored it in. So then instead of x, we're going to pick some test points. So I like to pick one to the left, the point itself, and then one to the right. So instead of x, I'm going to try -5. And I'm just going to replace x with that number, right? X is holding the place of a number we don't know. I'm trying 5, so I can replace it. Is -5 greater than or equal to -4? No, it's more negative, so that one does not work. And when we're graphing, we only color in what works or what makes this statement true. So we can fill in that blank. Skip that step, my bad. So then I like to pick the point itself. So instead of x, I'm going to try -4 is greater than or equal to -4. Okay, and so one of those at least has to be true. -4 is not greater than -4, but it is equal to -4. So that one works. So I get to color in this circle. You get to color in what works, what makes it true. And then I pick one to the right of my point. I always like to pick 0 if I can. Because when we're thinking about positives and negatives, what's greater than or less than, 0 is a good reference point for us. So is 0 greater than or equal to -4? Yes, right? If I don't owe any money, that's better than if I do owe money, if I have negative money. So 0 is greater than -4. So I get to color everything this direction. So anything to the right of -4 is going to be true. And this could go on for forever, so I'm going to draw an arrow. Saying that any number on this side of -4 is going to be greater than or equal to -4. So same thing for the next one. We're going to graph the inequality. 5 is greater than y. So I put my circle on +5. I'm not going to fill it in yet. I'm not so sure. Then I'm going to pick some test points. I'm going to pick 0. Okay, is 5 greater than 0? Nope. So 0 doesn't work. I'm going to pick the point itself. Is 5 greater than 5? No. Okay, that's not true. So I don't get to color the circle in. And then if I extended this line, right, we could pick a point to the right of it. I'm going to try, oh my gosh, 5 is greater than 0. My bad. I was thinking less than. Oops, sorry. So that works. Is 5 greater than 8? No, 5 is not greater than 8, so I don't get to color that way. So I'm going to color towards what is true. 5 is greater than 4, which is greater than 3, greater than 2. Anything this direction, 5 is going to be greater than that number. So I'm going to draw an arrow that says, if I continued coloring this line, any of those numbers, 5 would be greater than it. Okay? So a shortcut way to know is if it does not have an equal to line, it's going to be an open circle. If it does have an equal to line, it's going to be filled in. What we call a closed circle. Right, so on to solving. Okay. The goal of solving an equation or an inequality is to get the variable by itself. Right? A variable is a number we don't know, and we want to find that out. So we're going to have to get that on its own to figure out what it is. And the thing I use to help us figure out what's happening is we're going to circle the constant, and we box the coefficient. So that kind of helps us figure out what numbers are connected to my variable that I need to get rid of. Then the other thing with equations and inequalities is that we want to keep them balanced. So what I do on one side, I have to do on the other side. You must do on the other side. Alright, so then something we teach students, it's not really part of the math necessarily. It is just to help you keep your thoughts and your solving organized. So we draw a line through the equal sign, and that helps me figure out this side versus this side, and it helps me keep it balanced. So in the equation, x minus 5 equals 9.5. My goal is to get 1x. I want to get x by itself. So it needs to not have a constant, and it needs to have a coefficient of 1. Okay. So looking on the side with the variable, okay, I have a minus 5 that I need to get rid of. That minus 5, the operation that's happening to the x, is minus 5. We undo things by doing their inverse operation. The inverse of minus 5 is plus 5. So I'm going to do plus 5 on both sides. And then I just draw a line underneath to keep it organized. Okay, so minus 5 plus 5 is 0, right? Opposites are going to cancel each other out. We're left with x. Then I have to do the addition on this side. 9.5 plus 5 is 14.5. So that number we didn't know, we now know, and it is 14.5. On to this one. Y plus 10 equals 10. Our goal is we want to find out what is 1y. We just want one of the variable, no constant. Okay. The constant in this situation is plus 10. So what's happening to the y is that we're adding 10. That's the operation we see. The inverse of plus 10 is minus 10. And we do the inverse operation to get rid of things, or to move them. So we're going to do minus 10 on this side. Draw the line through my equal sign to keep it organized. What I do on the side of the variable, I have to do on the other side. Draw a line underneath to keep it organized. Okay, so 10 minus 10 is 0. Oops. And what I still have left on this side is the y. And then on this side, 10 minus 10 is 0. So that is my solution. Okay, and we might know that if I was going to do this problem, if I did it this way, what plus 10 equals 10? Oh, 0. Okay, you might have seen that already and known that, and that's okay. Just showing you for if you don't know how to do it, how you might go about it. All right, so this one, n over 2 is greater than negative 1. Our goal is to get 1n. I'm going to draw a line underneath my symbol to keep the sides of my inequality organized. Okay, the thing that's stuck with the n is 2. And that fraction bar means dividing. So the operation we see is dividing by 2. The inverse operation of dividing is multiplying. So to undo the dividing by 2, I'm going to multiply by 2. So then I'm going to do that on both sides. So I'm going to do times 2 on this side. What I do on the side of the variable, I have to do on the other side. So multiplying by 2 and dividing by 2 cancel each other out. And then we're left with n. Negative 1 times 2 is negative 2. Then I'm going to bring my symbol straight down. So my solution is n is greater than negative 2. All right, to graph that, we're going to put a circle on negative 2. And I'm going to color in any numbers that are greater than negative 2. It's just a greater than symbol, no equal to. Okay, and then anything to the right is going to be greater than that. Right, 0 is greater than negative 2. Positives are going to be greater than negatives. So I'm going to go towards the positive side. All right, last one. 6 is greater than or equal to 3x. My goal is to find 1x. Draw a line to separate the sides. Okay, the thing that is stuck with the x is a 3. This is our coefficient. A coefficient is the number that multiplies the variable. So this means 3 times x. So the operation we see is multiplying. The inverse of that, the opposite of multiplying by 3, is going to be dividing by 3. So I'm going to divide both sides by 3. Okay, 3x divided by 3. 3 divided by 3 is 1x. My symbol comes straight down. 6 divided by 3 is 2. So my solution is that 2 is greater than or equal to x. So I'm going to put a circle on positive 2. And I'm going to pick some test points. I'm going to try 0. Is 2 greater than or equal? And instead of x, I'm going to put 0. Yeah, 2 is bigger than 0. So that works. I'm going to put a little check mark to remind myself of that. Next one, I'm going to try the point itself. So instead of x, I'm going to put 2. Is 2 greater than or equal to 2? Yeah, it's equal to. That counts. So I can put a check mark there. Then I pick one point to the right. Is 2 greater than or equal to, let's try 5. So instead of x, I'm going to put 5. No, 2 is not greater than 5. So that side of the point does not work. We get to color in what is true. So I get to color in the circle, and then 2 is going to be greater than any of these numbers this way on the number line. And that's it.